Okay, so this is going to be kind of a long note packet, but then we'll spread out the work over a bunch of days. So if you can get started with your notes, then when you come back, we'll have a few days to work on all the problems. So 3.5 is about continuity, and I want you to be able to tell when a function is continuous or is not continuous, and tell the type of discontinuity. Okay, and discontinuity means that it's not continuous, obviously, but continuous means a couple things. It means like as you come upon this value from the left or from the right, as you're traveling on a graph, you never have to pick up your pencil on either side. And if I plug in that number, you can get an answer. So if you ever have to pick up your pen when you're drawing, it's discontinuous. And so that's kind of where we're starting at here. So if a graph has a hole, a break, a gap, we say it's discontinuous at that point. So the first type of discontinuity is called point discontinuity. And if you were drawing a picture of this, you would be drawing something and then you would happen upon a spot where it just doesn't exist, and that would be a point. And we call that like a hole. Okay, so some people just call it a hole, but there's a hole in your graph. And so it's discontinuous because I had to pick my pen up to move away from that hole there. Okay, infinite discontinuity is when there is an asymptote. And so what this looks like is if there's a dotted line here, and your function looks something like this, where it approaches the asymptote but never touches it, it's infinite if there's an asymptote there. Jump discontinuities back to our piecewise functions that we did back in 1.7, chapter 1 was 1.7. These are the ones that look like you would have like an open circle, remember, and then sometimes you'd have two closed circles, then maybe another open circle that went like this. So that's a piecewise function. That's jump discontinuity, meaning that like you're tracing your pen along this, and all of a sudden you have to jump up here and then trace your pen here, stop, jump down here. Okay, so that's jump. We won't talk about everywhere discontinuous, so you don't have to worry about that. If you wanted to know, I believe an example is the step function, but we are going to not worry about that and just call that jump discontinuity. Okay, so I'm going to do some examples for you if you want to like get started and try and pause and then go back and look and see if we have the same answer. You can do that, otherwise you can follow along with me. So this one I hope you recognize as a piecewise function. So hopefully you're thinking already this is probably going to have jump discontinuity. Now you could graph this and find out that it has no discontinuity, meaning that it's continuous. So I'm going to start with this one here. And when you remember, we have to start at -4, and then I have to pick numbers less than -4. I'm going to pick even numbers just because of that fraction 1/2. And then that less than or equal to sign means that I have to fill in the circle. So when I plug in -4, I think I get 3. Because I get 2 plus 1, so 3 plus 1 is 4. 4 plus 1 is 5. So here's my first one. I'm going to make this one. This one I'm going to start at -4 and pick numbers bigger than -4. And I have an open circle here. So -12 plus 8, -9 plus 8, -6 plus 8. So all of these are points that we're going to plot. So then let's see here how well I can do on my screen. -4, +3 would be a closed circle. 4, -8, 5. So this one, well, that was really wobbly, but that one's going to look something like that. And my next one is -4, -4, 2, and this one's going to go something like this. So yours should look like something similar to mine. And then I need you to tell me, and we already figured it was going to be jump, and then where? At x equals -4. The jump happens at x equals -4, where I had to pick my pen up and move to the next spot. Okay, so if I was drawing along this, I would come from, somewhere, stop, pick up my pen, and then start drawing again. So that's how I know that this one is jump discontinuity. Okay, so this one on the back, I'm going to factor this first. So that's kind of where I'm going to start. I'm going to start by factoring. So I think I have x minus 3, x plus 2 all over x plus 1. Okay, so nothing cancels or crosses out. We'll talk about that in the next one. So not much that I'm going to do, except for I hope that you notice that there's going to be a problem here where x equals -1. And that is going to be where we have an asymptote. So when I make a table here, and you can use your calculator to make a table if you'd like, I don't mind, or Desmos. I'm going to make a table. I'm going to make my table in black here. And I'm going to just pick some numbers. These are just regular numbers that I usually pick, nothing special about them. When I plug in -2, I get 0. You can plug these in on your own. When I plug in -1, I get undefined, and we've already guessed that that might happen because of this factor in the denominator. I have 6. We have 3, -1 1/3, and I had one more on my note sheet. It was 3, 0. It is okay with me, at least at this point in the game, if you are using Desmos to try to help you graph these, and I think that that's important. But what's going to happen here is that at -1 I have an asymptote, and you need to draw that in. So I'm going to draw it in with my red marker. You can choose something different. I'm going to put some of these points on here that I know. So -2, 0 was right here, and 3, 0 was here, and then 1, 2, 3, 4, 5, 6, 0 was here. So some of these that are like super easy to graph, I think they're easier to put in. That 2, 1 and 1, -1 and 1/3 is probably not quite as easy. And then hopefully you also have Desmos nearby, either on your phone or you can bring it up. But notice that this hugs this asymptote kind of like this, but never touches it. And so this is infinite. So whenever we have an asymptote, we have infinite discontinuity, and then again I want you to give it to me at x equals -1. So tell me right where that infinite discontinuity is. And I know I have an asymptote because if I plugged -1 into this function, I'd have 0 on the bottom, and then it would be over. Okay, so I've already kind of slid up and moved to this next one. I'm going to do the same thing where I factor. So hopefully you're feeling good about factoring still, because we need to know how to factor. And I'm going to get x minus 5, x plus 2, all divided by x minus 5. So factoring is important here because now what happens is something cancels, something crosses out, and these cross out. So if I'd said this, like 2 times 2 over 2 times 3, okay, this is kind of how you break, reduce fractions. I cross off both those 2, they're both factors, and I get 2/3. So I'm doing kind of the same thing here. What this is going to look like, this is going to look like the graph of x plus 2. So if you type this entire thing into your Desmos, it's going to look just like the line y equals x plus 2. The difference is this has a hole. And it has a hole at x equals 5. Because what happens if I plugged in 5 into this, I would get 0 in the denominator. And that can't happen. So even though I cross those factors out, I'm going to get a hole. So when I make a table of values for this one, and again, it's going to look like the graph of x plus 2. So I'm just going to make sure that I get 2, 3, 4, 5, 6. If I plug in 2, I'm going to get 4, 5. 4 plus 2 is 6. Instead of getting 7, like we want to say it's at 7, right? It's undefined. And 6 would be 8. So at the specific spot, 5 over 7 up. So I'm going to find that 1, 2, 3, 4, 5, 1, 2, 3. That's where the hole is. That's where it's undefined. I can plot the rest of these points. 2, 4. Okay, it just looks like this. But my line cannot go through it because I have created a hole in that spot at +5 where if I plugged something in, I would get a 0 in the denominator. Now, again, it looks like the equation x plus 2, but it's not. It's really that x squared minus 3x minus 10 all over x minus 5, and that's where the hole comes in. So you're going to tell me that this is point or hole discontinuity, and then you need to tell me the whole point that I dropped out. You need to tell me the x and the y, which we know is 5, 7, like that undefined spot where I'd put it in. I know that it's undefined here. It really is undefined. But to put it on my map, to put it on my drawing here, I need to have a specific spot, and that spot is at 7. That's kind of where it like falls out, okay? So those are my 3 examples. If I was going to write a summary of what just happened here, this is what I would tell you. So for those of you in Avid, you're probably going to like this summary. Okay, first step is to factor. Okay, always factor. If you can't factor, don't worry about it. Okay, if you get factors to cross off, you get a hole. Okay, so if you get factors to cross off, you have a hole. They cancel out. Okay, so there's it cancels out. That creates a hole. You need to find it. Okay, if there's no crossing out, no factors cancel. Okay, no factors cancel. Then there's an asymptote. AS. Okay, so after you factor, you look, did I cross something out? Did I cancel something out? There's a hole. Did nothing cancel out? Then there's an asymptote. Okay? The only other option then is for it to be a piecewise function. And this is jump discontinuity. So this would be like my summary, like how do you find, the holes, the jumps, the asymptotes. So this is what you're going to do. Your homework is going to be A through F on a worksheet. That's like your homework for these. That's kind of practicing all those. You should be using Desmos at this point to help with the table. You should be making tables and the picture. Okay, once you kind of have some landmarks drawn in there, you should be able to go in and like graph it, but you need to have some landmarks.